Three-phase semiconverter. Three-phase semiconverters are used in industrial applications up to 120 kilowatts, where one quadrant operation is required. The power factor of this converter decreases as the delay angle increases, but it is better than that of the three-phase half-wave converter. This is our circuit where we have three thyristors T1, T2, T3 and three diodes D1, D2, D3. T1 and D1 are connected to VAN, T2, D2 are connected to VBN, T3 and D3 are connected to VCN, and we have freewheeling diode DM. T1 can be turned on. The VAN is more than VBN and VCN, and T2 is turned on when VBN is more than VAN and VCN, and T3 can turn on when VCN is more than VAN and VBN. T1 is going to conduct until VAN is less than VBN and VCN, and T2 will conduct until VBN is less than VAN and VCN, and T3 is going to conduct until VCN is less than VAN and VBN, or until the next thyristor turns on. When T1 is on, D1 cannot be on, since the voltage potential here is equals to voltage potential here. For this, D2 and D3 will work. For this, D1 and D3 will work. For this, D1 and D2 will work. D2 will work when VBN is greater than VAN or VCN. D3 will work when VCN is greater than VAN or VBN. And D1 is going to work when VAN is greater than VBN or VCN. Now, this is a three-phase supply, VAN, VBN and VCN, where on x-axis 1 unit equals to 30 degrees or pi by 6. On y-axis 3 units is equals to Vm. T1 can turn on when VAN is more than VBN and VCN. So here we can turn on the T1, and here we can turn on the T2 which is connected to VBN, and here we can turn on the T3. Similarly, from here to here, minus VAN is more, so D1 is going to conduct from here to here. From here to here, D2 is connected to VBN, so D2 is going to conduct. And here, D3 is going to conduct. Here, D2 is going to conduct. For our case, alpha greater than pi by 3. When alpha is 90 degrees, we can turn on the thyristor T1 here, but we have alpha that is 90 degrees, so here I am turning on the thyristor T1. T1 is going to conduct until VAN is than VBN and VCN. From here, if you observe, VBN is more than VAN, but VCN is less than VAN. So thyristor is going to conduct up to here. Here, T2 is going to turn on at an alpha of 90 degrees. So here, T2 is going to turn on, and this is going to conduct until here. T3 is going to turn on here, and this is going to work until here. So here we can write this is until. When this condition reaches, thyristor stops conducting. The area in between these two curves is the voltage output. You can observe here T1 is turned on and here D3 is turned on. So this is the area under T1 and D3 is going to work. This is the area of the curve, the voltage which appears across the load. Here T2 and D1 is going to work. This is turned on, so area under this curve is this. T3 and D2 is going to work. Again, here T1 is turned on, so from here T1 is going to work. So before T1 there is a T3. So here T3, D2 is going to work. To redraw this, this is our output voltage, this is our input voltage Vs. T3, D2. So T3 is connected to VCN and minus D2 is VBN. The voltage appears is VCB. T1 and D3. T1 is connected to VAN and D3 is connected to VCN, that is minus VCN here. So VAC. Here T2, D1. T1 is connected to VBN minus VAN, T1 is connected, then VBA. Here T3, D2, VCN minus VBN, this VCB. In this area, there is no output voltage. So this is a discontinuous output voltage. Currents is going to appear from 0 to 90 degrees is due to I T3, I D2. From here to here, I T1, I D3. And from here to here, I T2, I D1. And from here to here, I T3, I D2. In between these blocks, when no thyristor is turned on, since we have taken the high inductive load here, the current is going to circulate through the DM. So there is a possibility of getting IDM. That IDM is going to work in between these areas. When this freewheeling diode is removed and the alpha is less than or equal to pi by 3, that is 60 degrees, alpha equals to pi by 6, that is 30 degrees. When the alpha is 30 degrees, this is where we need to start, that is pi plus 6 plus 30, pi plus 6, which is nothing but pi by 2. At alpha equal to 30 degrees, the thyristor T1 is triggered and it is going to conduct until VAN is more than VBN or VCN, or T2 is triggered, the next thyristor is triggered. But the next thyristor is triggered at an angle of 30 degrees here. T1 is going to conduct from here to here. Here T2 is start conducting, and this can conduct until the T3 is turned on. T3 is turned on at 30 degrees again here, T3. To here, here again T1 is turned on. Before T1 there is T3. This is T3. This is a new output. Let us try to draw the output voltage for alpha equals to 30 degrees. The T3, D2 is on. Between these two, T1 and D2 is on. T2, D3. This is T3, that is VCN minus VBN. This is VCB, and in between these two, T1 and D2, that is VAN minus D2 is VBN. So VAB. Now the currents IT3, ID2, IT1, ID2, IT1, ID3, IT2, ID3, IT2, ID1, IT3, ID1, IT3, ID2, IT1, ID2, IT1, ID3. Now this is our output current, output voltage for alpha pi by 6. Here there is no freewheeling diode, so thyristor T1 will work until T2 turns on.